All right, so the other day we talked about domain. Right, we go back here. We did all right, we did these four the other day. If you need help with those and you're gone, just let me know. All right, so we'll start with determine the domain of functions. So that's what we're on here. Everybody can see that, right? Easy enough. Okay, here you go. It says, what's the domain of f? So domain is the numbers that we are allowed to plug into an equation that will give us an answer when it pops out, right? So the other day we noticed in fractions, if you plug in certain numbers, you might end up with what bad number on the bottom? 0, right? So what you should ask yourself is when you see a fraction like this, what number would make this equal 0 on the bottom only? -2. So the way we'd answer is we'd say we can use every number in the world except for -2, right? And that's what it's saying. It says all real values of x such that x is not equal to -2. So that's what you'll be doing on this assignment, right? Fraction ones are easy. If you see something that's not a fraction and it's not a square root, then the answer is going to be everything. Okay? There's nothing that we could plug in there that would result in an error on a calculator, right? If we tried to do it, no matter what kind of number you did, you can square any number. The problem is, what happens if we have a square root? What are some numbers that you can't take the square root of? Right, yeah, you can do positives, right? And you can't do square root of negatives. So when would this thing start to turn negative? Would it be when x is 0? No. Well, that's true, but that doesn't account for every possibility. So here's what I mean. If I plug in, say, 11, and I do 11 minus 10, I get the square root of 1, which is 1, right? If I do 10, so 10 minus 10, I get 0, which is still an answer. The problem happens when I go down one further. So I started with 11, then I did 10. Once I go under 10, right? That's the problem. So think about what I'm saying. Once we plug in a number below 10, we can't do that, right? So if we go under 10, then what? If we go under 10, it won't work. So how can we say it will work? Anything that is right there, right? So anything that is greater than or equal to 10. So what we're doing is we're figuring out what won't work, but we're answering what will work. All right. So that's kind of the odd part on this. They're not asking you what doesn't work. They're saying choose the domain. And the domain is the list of numbers that will work. Okay. So this one gets a little confusing, but there'll be 3 kinds. It's either fraction, square root, or something else. Right. Okay. Next assignment is also with domain. This is going to look very confusing, but if we cut through the baloney, it's really easy. All right. So here's what's going on. It's talking about somebody's been sprouting 2 days before they bought it, had 98 days until it died. It's a plant, whatever, right? So the height, h of t, models the height of Pooja's plant, t days after she bought it. Now, we're talking about domain. Domain always refers to the thing that we plug in. All right, domain in this situation is not talking about height. Domain is always the number on the inside of the parentheses. What do we plug in? All right, so what do we plug in? T. And what is T? Right, T is days, right? So now we have to ask ourselves, all right, how do we measure days? Do we measure days by integers? Integers being like numbers like this And in other words, there can't be a half a day, or there can't be a 0.2 of a day. Or do we measure it in real numbers? Like would have answers like this: 1.1, right? 2.47, anything else, right? An integer is like a whole number. So this is kind of tricky. But how would you actually measure days? Do we count days by a whole number? Or do we count days by saying we are at, like, for example, right now, how much of a day have we had? Can we answer that? You could, right? With a decimal, couldn't you say? It's a certain fraction of a day. Yeah. So I'm not sure how Khan's going to interpret this, and I'm not sure how, but in my mind, it's a real number. All right. So I guess we're going to know. All right. So what's the appropriate domain? So in other words, what can T be measured from? Well, when did Pooja get the plant? 2 days. Right? And then how long did it go? 98 days. So which one is it? What's the answer? Oh man, what the heck, right? So this is H models the height of the plant, how many days after she bought it? After she bought it. Oh. She had it for 98 days until it died. It had been sprouting 2 days before she bought it. This is the keyword that I see. Right there, right? So it sprouted 2 days before she bought it. T is the number of days after she bought it, which is kind of confusing, right? So if it sprouted 2 days before, it's like saying a negative. I'm still not sure how Khan's going to accept this one. Hey, we're right. All right, good. That can be kind of tricky. All right, here's another one. Which type of number is more appropriate for the domain of R? Let's go back up. Domain is on the inside. What is M? Months. Months, Trevor. Okay, which type of number is more appropriate for the domain of R? This is monthly rainfall. I'm going to say integers. I'm going to say integers. When we see the table here, we see that there is a list of data corresponding to each whole number, right? That tells me it's integers. All right, now what's the appropriate domain? Domain is months. So for the years 1900 to 2009, all right? So does this matter, or are we just looking at 1 through 12? What do you think? Yeah, we're not counting the years, right? We're talking about months, and we're not counting all the different months in between 1900 and 2009. That would be a big number. I have no idea what that would be. All right, bingo. All right, the difference between this one and the one before was we were talking about days, right? And we're talking about the plant's height. Plant's height at a half a day can be measured, can it? What they did here is they took all of the Januaries and they said, what's the average rainfall? They took all the Februaries and what's the average rainfall? They didn't say what's the rainfall in halfway through January. Okay, so that gets kind of funky that way. All right, move on to the next one. Here we go. Recognize functions from graphs. So we talked about domain. Now we're talking about whether something is a function or not. Here's the rule. It's a test. It's the vertical line test. You can do it with a pencil on your screen. Just kind of line it up, and then you'll have your answer. All right. So is this a function? This answer is yes. Here's how I know. It's impossible for me to draw a vertical line at any point in time and touch the graph more than once, isn't it? Can I draw a straight up vertical line and ever touch this graph, the blue line, any more than once? No. So that means it passes the test. Does So that means it is a function. Okay, now let's try a different one. How about this thing? There's so if I draw a vertical line anywhere, right? That wasn't very vertical, but again, but that's, you get my point, right? There are two different locations when x is -2. So this fails. Fail. We can make our own like Snapchat channel with function failures. Would that be cool? Sure. Okay. So anyway, this is not a function, right? When it fails like that. Another one. How about this? Not there. Oh, wait, look here, right? All it takes is one failure. So this is not a function. It touches the line twice. Last thing, same idea, but now they're not going to give you a graph. They're just going to give you a table. All right, can the number of people who visited the park be represented as a function of, all right, can the number of people who visited the park, can the number of people who visited the park be represented as a function? So, of the daily average temperature. So in other words, what we're looking for is any repeats that are different. So here's what we're looking for. 16 I see on here twice, don't you? And how many visitors were there? Was there a different answer than 27? No. So what that means is it can be used as a function, because when we plugged in 16 into the function, how many answers came out? Just one. And that's a useful function. All right, so that's what we're looking for. Look for any repeats over here. How about 11 though? 17? Still the same, right? So this is a function. Awesome. How about this one? Type of hat. Let's look for repeats. I see beret on there twice. Daffodil, daffodil. Any other repeats? This one. They're the same, right? So that's a function. Let's find one that's not a function. 180 and 180. Oh my gosh. That's a function. Oh, the 220s are different. 220 gives a different number right here. That's a failure. That'd be like a vertical line test failure. Okay, it's the same idea. So that's not a function. Yay! All right. If you have questions, ask me. Let me assign them.